And we are live. So, welcome to Expressive Projections live coding session. In this session, you are going to write some event-sourced projections with Matthias and Eric and also Romeo. I don't think I need to introduce these people to you guys, actually, in any event that is related to domain-driven design. I am Zsófi. I am the host for this session today, and I'm also going to be watching your comments in YouTube and Zoom. So please, if you're struggling with anything like reading the screen or have any problems, please do let us know there. I mean, in YouTube or in Zoom. And now turning to Matthias, actually, to kick off the live coding, and you enjoy the session.
All right, thank you, Sophie. So the goal for this session is to look at some code and do some refactoring and have some conversations about it, and it just goes wherever it goes. Whatever happens is what's supposed to happen. So it's well, Eric and Romeo. It's basically choose your own adventure. So just well, we'll see where it goes, right? So I'll start with just explaining the domain we'll be using. It's something that was created by Thomas Koopman and Michel Grootjans. It's like a kata for event source projections. It's basically a quiz, so people can, players can sign up, create their own quizzes and add questions, publish them, and then people can start games. So a game is like an instance of a quiz. Players join and then, well, they play it. Most of this we'll probably not even bother with for this session, but just to give you some idea. So this might be the outcome of an event storming session, and basically we expressed our entire domain as domain events, right? Something that has happened in the past that is relevant to our domain. So just stop me if it doesn't make sense. What do we have? Well, we have some code that basically represents this. So this is Haskell, by the way. I didn't warn anybody up front that it was Haskell. So you can still switch to another session maybe, but it should be fun. You don't need to know any Haskell for this. So as you can see, we have a bunch of types. They're basically records. And our domain event type is basically a sum type of all these domain events with some properties that I think are pretty obvious. What else we have? We have a data set that was randomly generated. It looks like this, just a whole bunch of JSON. In the real world, of course, this could be an actual database and some way of streaming it. And then, well, the goal will be to actually derive useful information from those events, right? So we have a whole bunch of these events stored somewhere, but we want to interpret that and derive useful information from it, which could be statistics. That's what the examples are going to be, or just game state, or anything really. What else should I show you? So we have an event store is, well, the abstraction for that database here. It's just a file, so we don't really need to worry about how that works. And let's actually try to write our first projection. So I have some code set up here. We're basically going to replay all the events from that event store into our projection. Our projection here is called count events because the first thing we want to try is just figure out how many events are in that event store. So, and I've already built an abstraction. Basically what we're going to do is we start from some initial state, and then we're going to process each event and update that state. Normally in an imperative language, that would look something like maybe you'd have an initial state, and then for each, well, let's say event in events, oh, like this, we would do something. So maybe let's call that result is our initial state. So what we would do is for every event, basically add 1, and then that's our when we're done with this loop, we basically have result, which is now a count of all events, right? This is imperative style. This is an explicit loop with some state that we're modifying, right? So it's mutable state. In a functional language like Haskell, we would actually abstract that a little bit, because this is a pattern, right? It's doing this over and over. This would already be too much boilerplate for a functional programmer. So an abstraction, let's say that let's put this in a function. So let's call that f for now, and so it looks like this. And
should we call it reduce or sum?
Yes, that's where we're going. This is a fault, right? But I want to make sure that you do closure, right? So you know what faults or reduces are. I want to make sure that that we've covered the basics here, because if there's people who don't know what a fault is, then the rest of the session would be useless to them.
Also, could you make the font bigger?
Sure.
Since there's plenty of room, especially. I think people on laptops will appreciate it.
How's this?
Well, it's incrementally bigger.
So yeah, this is basically what this f is going to be, a fault, and but I want to show how we get there, basically by making everything in this code an argument to that. So the initial value, we could already put that here. We say that's our starting value, or list of things that we're going to loop over. Well, let's call that well, X's would be a good habit. So let's put that here, and then basically this the thing we're doing, the function that we're applying to that over and over again, is we can abstract that as well. So we could say this is some function g that takes the initial value or the previous sorry. It would look something, well, I should have written this, return result. So basically we return the initial value and the function applied to, let's see, this is what I'm looking for. I think that my editor is being slow with Zoom, so that's a little bit annoying, but we'll make do. So basically it's this now. We for every, well, let's call that x, for every x in our list, we apply.
So you made it recursive.
Not yet. Here we're still using for each. We're still looping, and we're applying. Sorry, this is the mistake. This was function g.
Oh.
Sorry. So now it's not recursive. It's still inside. It's still imperative code, right? It's still a for each, but we're simply applying now the function over and over again. Well, it's still, sorry, it's still like this. Actually, it's still. I'm mixing two styles of programming. This was probably a bad idea to do this. So actually, if we were to rewrite this as a proper fault, we would actually do it recursively. But basically what I'm trying to get at is we have a fault that takes some function, and what it does, so what this function does is it takes another function, and this function is applied over and over to a value, the first value from X's, takes that value, applies the function again to this new value and the next value from X's, and keeps doing that. So actually, maybe the better way to explain this would be to visualize it like this. We have an initial value 0, for example. We have a list of values, and now our first iteration applies our function f over 0 and 1. The result of that, if our function f is a plus, for example, so So like this. All this will look like in Haskell. So if we apply now plus over 0 and 1, we get 1. Then we apply it again over 1, and the second value from our list, which is 2. And we do that again with the result of that. So that's 3 with the last item from our list, and then we get our final value. So that's what the fold does. A very basic. Actually, let's show that. If I have a function plus, we have an initial value, and we have 1, 2, 3. We should get 6.
And just to make the point, if you change your initial value to some other number, not 0,
we get 16. There's actually another fold that doesn't require initial value, which we don't need here, but this is also a fold left. But instead of starting from an initial value, it just takes the first item from the list and then keeps adding the others. So in this case, that would also result in 6. The interesting thing about, so we got rid of this whole for each thing. The interesting thing about that is, well, first of all, we only need to worry about what our function looks like because all this code is already abstracted somewhere. The other interesting thing is that we can do this to anything. We can do this to any kind of data structure. If we had something that was a tree like this, we could also do a fold over a tree, which would then, based on how it's defined, it could say, well, go to the left first, take those values, and then fold them using our function. So the result of a fold on this would also, of a fold of plus, would also be 6 on a tree like this.
Since addition is commutative, there's no difference between a left fold and a right fold.
Yes.
But if you had an example, say appending a string or something, where you could see that sequence does matter.
Yeah, or even, I think it should even show with subtraction, right? If we have, why does this, I need a 0.
I don't think.
So
it's more of the case of associativity than commutativity. You don't need full commutativity, but you do need associativity.
Well, I mean, to make the left and right fold be the same.
Oh, yes. Okay. Oh, sorry. Yeah. Totally.
But I was just, because there are those who are not as familiar, like, for example, I'm more familiar with the terminology of reduce, but I just wanted to clarify what the left fold versus right fold was. And I think your tree example makes that very clear, except if you used, say, appending a string instead of adding a number, it would be more clear because adding a number, the left and right are the same.
We can, this is append, so we start with an empty string. We do A, B, C. I think the fold left will still give the same result here because
it's not a tree.
Because it's not a tree, and then but also because so the reason that for subtraction we get 2 different values for folding left or right. For this we don't, because the order with a fold left and a fold right, the order is the same, but it's about do we process from the outside in or do we process from the inside out?
I must admit that I'm really surprised by the fold right on subtraction. I would have thought you'd have gotten the same answer. So explain, why do we get that answer on fold right on subtraction?
So if we do, basically, it's fold left would be like this, -1, and then we take the result. So I think we need to draw it like that. And then the next iteration we're like that. So
okay.
This is so this is -1, this is -6, and then the right fold is 0, -1, -2, -3. So here we are, -1, 1 minus -1 is, wait, am I doing this correctly now? Why did I get 2? Maybe I'm still wrong about this.
Well, this seems like it would be 0. Oh, wait,
oh
no,
yeah, this would be, sorry, so this is -1, so this is 2, so this is 0 minus 2, and then we end up with the no, this is -2, and this is 2. That's how we get there.
Okay, well, we shouldn't spend all our time, I suppose.
I'm sorry, your sound is has gone away, Eric.
Oh. Well, I didn't know. Anyway.
Oh, there is some noise.
Can you say something, Eric?
I am saying something, but it's not working. So
yeah, we can understand you. It's
going.
All right.
You keep going.
So so let's actually do our so the actual fold happens elsewhere. I already have this replay function here, which basically takes an event store and a projection, and then basically gets those functions from the projection. So here we're saying do a fold left, stream these events. So the thing I wanted to mention about folds being more generic than just lists, they can operate on trees, but they can operate on things like streams, which are really like lists with time in between them, in a sense. So the nice thing is that our code doesn't change no matter what the underlying implementation is, or what the underlying data structure is. So even though in my code it's not a real stream, it's just a list. But if it were like stuff coming in over time through some message bus, for example, my code would still be exactly the same. That's the elegance of folds as a very generic way of doing something. And so here I get the initial state, which is the 0 in our counter. I get that step function, and then here we run the fold. And then finally, there's a transformation step, because the result, sometimes we want to do something with that state, but we'll get there later. So when we execute our code, what's really happening is just here, this stuff being pushed in that fold. So let's actually make that work now. So our step function takes some initial value, which is an n. It's just a counter here. It takes an event. So for every event that we have in our history, we will run this function again, and then we basically increment it. So we can even ignore the event because we're just incrementing a counter here. So if I got this right, this code should now work, and we see that we have 13,000 something events in our database.
That is a long quiz game.
Well, it's not one game, it's the entire history of the system. So every time anybody started a new quiz, added questions, answered questions, joined the game, etc., each of those is an event that is in our database. So this would probably be not that much in a production system.
I see.
So far so good. This is of course the simplest projection we can think of. It's just count everything. So we can do something more interesting now, which is counting the players. So let me just swap the function that the projection that we're going to use here. I already added a little bit more code here. So we're saying we start from every step, we start from some states and we do something. And so here we actually need to get the payload from the event. So let's have a look at the events again. So this is sort of the generic event type. It has an ID and the type and the timestamp, and the payload is the domain event that we actually care about, right? So this is sort of some generic stuff, and this is the domain-specific stuff that we got here, right? So now we're only interested. We're not interested in for this projection in all of this stuff. We just want to know something about the domain event, because what we want to count is every time that a player has registered, right? So what we're doing here is pattern matching on the type of the payload of the event that is being folded into our projection. Make sense?
Yeah,
Makes sense.
a filter.
Yeah, you could think of this as a filter. So basically, if we have a player has registered, we need to increment our state. If we have anything else, which you can write like this, we just return our state as is. And this should be enough to make the projection work. Yeah, so we have 53 players who have registered. Now the point of this talk was to sort of show how to make our language a little bit more expressive in our projections. To me, a word like apply is so I already like this habit here. It's naming your events as sort of sentences that could happen in the domain, using the verbs in there. So not player register event or something like that, or player event, but a player has registered. Right? That's more natural.
Yeah. That's a convention of the event sourcing community for sure.
Well, I'm afraid that the convention is something like this, which I think is still a missed opportunity to make it a little bit more natural. If I do event storming sessions, for example, with non-technical people involved, this seems to work a lot better. It's how you tell stories, right? When that happened. So when I see a word like apply, that's usually that's one of those words that programmers use when they don't know what to call something, right?
When something's so abstract that it no longer, that
so
normal words no longer apply.
So even though technically we're applying something to the state, but I think I like this naming style, where you just call that when. So now we have when a player has registered, increment the state. And well, actually, I need to change this one as well, of course. Yeah, the refactoring feature here for the Haskell plugin is very much in beta, so not everything will work.
So, so then anything that doesn't match the first pattern falls through to the second one.
Yes.
And then everything matches an underscore.
Yeah, I could actually match other stuff, of course, as well. Maybe, let's see, which would make sense. We don't have players unregistering, but we could do something like this if they join a game.
So now what we're saying is count the number of times that a player has registered and or the player joined the game. So you've kind of made it.
Of course, this doesn't mean much. Why would we add those two together? But it could. So this would make more sense if we had a player has unregistered or something like that. And then, of course, here we could do something like that, and then we'd know our actual active players or something like that.
Yep.
So let's move to this. So what we're going to do now is count the 10 most popular quizzes. Ignore this. This is just for formatting reasons. So this one I already I wrote it so we can refactor it. So here we need the most popular quizzes. So what we will need is basically every time that a quiz was created, we'll need to track that quiz so that we know which quizzes exist in So users can add their own quiz. We want to know that. And then every time a new game is opened, so an instance of the quiz is people are playing an instance of the quiz basically, then we need to then we actually increase our or we increment our counter. So this way we know how popular every quiz is. I think Romeo has to leave in a few minutes. So if you're leaving, Romeo, thanks for joining.
Did you have any observations, Romeo, before you leave? Oh, you're muted, by the way. Your mic is muted.
I think the interesting part was about to start, so I'm kind of frustrated, but I try to come back as quick as I can.
All right.
Yes, I know what you mean.
Over already. All right. So so basically we need to. So I made a type here that expresses this thing, and we also wanted titles for presentation purposes. So we now need a map that tracks quiz IDs, so we can find them again. And then track the popularity of each quiz, and then at the end we will just get the 10 most popular ones from that. So if you look at our we need to keep track of this because the only place where we know about the quiz title is in the quiz was created event. So this one has a quiz title field, but game was open doesn't have that. So the only way to keep it is to actually map it somewhere or store it somewhere so we can look it up later.
So just to clarify, so popularity is defined as the number of times that the game was opened.
Yes.
Is that right?
Yes. So and then so basically this is now we will need our transformation. So our step is just a fold like all the ones before. We insert a new quiz object or record into our map whenever a quiz was created. We increment the popularity whenever a game was opened, and then at the end we will have to take all these quizzes and basically sort them on popularity, and then take the first 10. That's our transformation step. So we're doing this. This is the transformation is something we only do once. The fold, we keep doing it over and over on every event, and the transformation is only at the end. Right? So this code actually, well, should work. So let's try that. So here's our list of quizzes from most popular to least. Well, from the 10 most popular, basically. And now I want to, which was sort of the goal of this talk, is to refactor this code to make it a little bit more readable. I don't think it's very bad. I just think it's there's opportunities to make it better.
So just a note. So map adjust means to change the values in an object like game was opened.
Yeah. So basically, what we're doing is this is a function that we pass our state. Our state is a map of from quiz ID to quiz. So we pass that that state. We look up the key quiz ID, and if we don't find it, nothing happens. We ignore it. If we do find it, then we apply this function, and this function is taking a quiz,
incrementing its popularity.
Yes.
Yeah, I see that part. Okay.
So this is maybe a more elegant. So as we're talking about refactoring anyway, this would be something like increment popularity, and we could now move this function here and name it. So that already makes it a little bit more readable. And,
yeah, although I'd get rid of the R or spell it out. I've never seen increment abbreviated as inker. Although it could just be me.
I don't know. I think inker is more, well, let's
That's fine.
solve the problem.
Now,
So so here, actually, I want to make a side discussion here before we continue refactoring. I have been explaining bounded context to people as lately as understandability boundaries. Right. The whole question is, can I understand this concept autonomously, or can I only understand this concept in relation to these other concepts? And is that vice versa? Can I explain these other concepts only in relation to this first concept or not? And that's sort of the driver for where these boundaries need to be. If two supposed bounded context, you need to understand one in order to understand the other, and vice versa, they're not really bounded that well. And of course, there will be things that they need to share that they both need to understand. But that should be a small layer of shared concepts.
a shared kernel, you mean?
For example, yeah, or an interchange context. So
anyway, how does that bear on this, though, given
that I think that this thing is not a quiz, because the point of this thing is to track popularity. And popularity is something that does not exist in this domain at all. There's no mention of it. This thing doesn't care. So, and on the other hand, this projection that wants to find the most popular quizzes needs to understand something about quizzes, but adds its own language to it. In popularity and tracking popularity and concepts like this. So I think that very often projection can be seen as a small, well, not necessarily small, but often a small bounded context that can introduce different concepts, language, model, than
so you're talking about
the model it depends on.
The context of playing a game, or the context that a player would be doing while they're playing, versus looking at the set of games, thinking about. Yes, that could be another context.
So
it could be another module within a large context. It depending on how meticulously we align the two. But it certainly should be somewhat decoupled, I agree. Either into a separate module or possibly an entire different context.
Yeah. So that different context could be statistics or something here, or analytics. Game analytics.
Romeo, you are muted.
I think he's in his other meeting, so we should just ignore him.
He was gesticulating Romeo style, and I thought he was trying to talk to us.
No, I think he's in another meeting.
Well, that looks much more exciting. All right.
So basically, I think that separating things in bounded context gives us the freedom to either to think about these names separately. We can either say, well, let's just call this a quiz, but it's not a quiz in the quiz context anymore. It's a quiz in the analytics context now.
True. So I do think, by the way, we should be mindful that we have about 20 minutes left.
All right.
So we haven't actually refactored anything yet. Well, except that.
True.
Increment,
so what would you call this thing? If would you rename this, and what would you call it?
Well, talk about how you would use it a little bit. Like, when does this come up? Does a person is it for the purpose of a person who's trying to decide what quiz to do, or is it,
for example, we could have
for the company that's trying to decide the most profitable? I mean, tell me a story about it.
Okay, well, choose your own adventure. Let's throw the dice, and let's say it's for the front page showing the most popular quizzes, so users can decide which one to play.
So the purpose of this thing is to help a user decide which quiz to play, and so it's kind of potentially would have other things that make a quiz more or less interesting, right?
Yeah.
Like you could think of it as points of interest or interesting things that make a quiz interesting. Would be its popularity, maybe its difficulty level, or its other. You can imagine things about it.
We could call this, based on what you're saying, maybe call this a recommendation, because we're sort of recommending.
Well, that's a good working title anyway, until we find out more about this thing, right? So
yeah.
It's certainly more clear than calling it quiz. Because quiz, as you say, is the actual series of questions and so on.
The refactor failed.
Is this really the best tool we have for doing this?
So sometimes it's
Control R or whatever.
Yeah, sometimes it works and sometimes it doesn't. So I don't know when it does and when it doesn't.
Okay.
But the nice thing about Haskell, people say that if it compiles, it works, and that happens to be true most of the time.
Most of the time.
If it compiles, that everything is correct. That you're.
So.
Anyway.
All right. So anyway, now what we have is we're saying, okay, we have a recommendation, a quiz ID with a title. That's just to know what it is. And then the popularity. Right now, that's our only indicator of.
Yes. Which is fine. We're not going to.
This is a toy example.
Yes, but so this this thing here, we're using this type everywhere. It's our map from quiz ID to recommendation. I think we should start by putting that somewhere else. So that's a type alias state like this, and now we can just do it like that everywhere that we use that, just for clarity. And,
so this is putting it into the language of event sourcing. To be clear, you're really drawing upon another context, the context of our event sourcing concepts.
Yes, so I'm doing this as an as an intermediate step, because my next step now is to think about what does the state represent, right? This is what you're getting at, right?
Yeah, but I'm just saying that it's good to have that state event state thing there, I think. That communicates to a programmer who knows event sourcing that, hey, we're doing event sourcing, and these are the pieces. A state, an event produces a state. I'm saying, though, that is, of course, distinct. That is the context of event sourcing itself. Now, you're about to say, now, in the context of quizzes, the state is this.
Yes. So we went from the language of maps to the language of event sourcing, and now we can actually say something like in the language of our domain, it's recommendations, really.
Well, it's not generic recommendations. It's recommendations of quizzes. It's quiz recommendations.
Sure. And well, would you want to rename it here, or do we assume that we're in the quiz recommendations bounded context, therefore recommendations are about quizzes?
Okay, given that we have 15 minutes left, I say let's stick with recommendation.
So then I would get rid of this of language this is still map language. So I want to start from empty recommendations, for example, which I could.
Well, I wish it were cheaper to rename things in this.
I know. It's
because I would have said, I almost said, I don't like that name, and we should think about it before you put it everywhere. But that would be very bad practice. We need a good renaming tool.
Yes. So as I said, sometimes it works and sometimes it doesn't. So here, actually, let's try renaming this one and see if it wants to do it.
Oh, are we going to lose our state event state thing?
Well, I'm trying to see if it's, so it didn't, I think I know why it doesn't do it, because it needs to update.
See, I actually like having a thing there that says state, event, state, and then connecting that to the domain-specific state and the domain-specific event. That, to me, that really kind of meant something.
Does it do? Oh, and now it's working. See, for some reason.
Yeah. Well, that's much better.
Yeah, and then we can do
but
what
now
you're
we've
saying.
Lost.
This.
State.
Again. So for some reason, sometimes it works and sometimes it doesn't. It's technology, right? So given we have a little time left, so I would basically do this. Start looking at this as well, right? Here we're still. This is the language of our domain, and this is still map language. So here I would say we're starting to we're tracking this quiz, which we weren't tracking before, right? We're inserting it. So given that this is the first time we see this quiz, it was just created, I would put this somewhere in, let's call it start tracking. And then of course we need to pass in some arguments. And again, in a more mature tool, this should be an automated refactor. So let me just align that a little bit. So now we can say that when a quiz was created, we start tracking for the quiz ID and quiz title and our state, which we should probably rename to recommendations. So now here, this is already a lot better, right? This is pure.
Well, okay, so it's time to slow down and let us catch up. So,
all right.
So we've got recommendations with an event produces a new recommendations. We've got recommendations event equals payload. Then say when a quiz was created. Okay, you keep moving it around.
Oh, sorry.
When quiz was created and we have a quiz ID and a title, we start tracking the quiz ID and the title. And then when the game was opened.
So here we can do the same thing now, where we say
when the game was opened, it's time to
something like this.
Yeah.
I'll put that here.
Well, how about increment popularity? You already have increment popularity, and it's a more expressive thing anyway.
Okay, I'll.
So Matthias.
Yeah. So I'll.
You
I'll
already
just,
have it.
Yeah. I'm refactoring it. So.
Okay. I think it's a better name than update popularity.
Let me just make sure everything works again. We have to pass our quiz ID and our recommendations. And here we need that's this one. And now we just need to pass in the arguments in the function, and this will work, I think. Let me just try that. We're still calculating the quizzes correctly. So, and then you're saying update popularity should be called increment popularity. And if
I especially thought that back when we already had a function called increment popularity. But yeah, see, update popularity is a very general sort of thing. It could cover a wide range of concepts of popularity, but our concept is a very simple integer. And so why not be honest about that when we talk about changing the popularity? How do you change an integer? In this case, we're incrementing it. So I think it fits.
This is sort of a Haskell thing that I don't have much time to explain, but because this function is now really just an alias for this one, and it's taking the same, the same arguments, we can actually eta reduce that, which is a functional programming concept. And this is a refactor that does work. So we actually made our codes a little bit shorter now, and same thing here. But this is out of scope for. But it becomes a bit more readable.
Can you let us look at it and understand what it's saying and see if it is? So you're saying start tracking takes a quiz ID and a quiz title, and it maps insert, whatever that is, and then it does a recommendation with popularity 0. Okay, so that creates one with popularity 0.
Yeah, and this
And
one we could
then-
actually make a little bit.
You have to give people time to read it before you change
Sorry.
it.
Okay, I'll try to go a bit slower then.
Sorry, guys, we have 5 minutes left.
Oh, okay.
Okay,
So, but now we're saying when we start tracking, we insert quiz ID and new recommendation. The whole map itself has become implicit in the. We don't need to pass it explicitly anymore, even though it's actually part of the type. But that's the thing we don't have time to explain.
well, let's just see if people. So first of all, does it actually run? Because I see a squiggly underline.
Yeah, that's just the redundant brackets, which are now
and
gone.
Then
and then if
I see a squiggly red underline.
Yeah, I think that the formatting that went wrong. No, this is, let's see. I think I messed up my refactor. Oh no, I know what happened. So definitely beta, because it's somehow, or no, that was actually me doing joining the lines too much. So probably it should work now.
So I don't know Haskell, but I'm gathering then that formatting actually has effect on.
The indentation is matters, yes.
Okay.
For scope.
Interesting. All right. So since we only have a few minutes, let's look at what we have here and see if we think it's more expressive than before.
Yeah. So here.
And that means not moving it too much. Okay.
Sorry. Yes.
We've looked at. Okay.
So I want to rename this stuff. So here we're saying we start with empty recommendations, and
which,
then
by the way, I think is not a very domain meaningful.
Sure, but we don't have time to improve it.
Well,
anymore.
We could.
Okay.
What do you really mean when you say empty recommendations? I mean, a game that's never been played, right? Or
No,
never even been opened once.
Yeah, this is the collection of recommendations, which is empty when we start. So we're still talking about the initial state of our projection here.
Okay.
So I think it will.
Okay, then quite an interesting thing. But so let's keep going.
So every step we're basically I would call this, for example, tracking or track popularity. That's what we were doing there. And then the final transformation is when we have that map of recommendations, and we basically sort it on popularity and take 10 items. So in a sense, I would say this is well, I mean, the name of this thing could just be get 10 most popular. And so this thing is, we can think of it as transformation, but it's really a query on the state. And now I would actually go maybe a step further and say a projection starts with an empty bunch of recommendations. Then, well, then is a reserved keyword, but I'll add then we keep tracking the popularity. That's our fold over and over. And then finally.
So I'm not big on these words because you've kind of gone full circle back to rather generic words that are often used for other things. Like finally means a lot to a lot of people.
Sure, but maybe this is too far.
And it isn't done. It also isn't done in this order. You're doing each one of these things continuously each time. I mean, we always have a most popular, a 10 most popular. Maybe select would be the select the most popular.
Okay.
The you say track popularity, but really we're incrementing, because I think
Yeah, but the
sometimes
increment
we make them too generic.
Yeah, maybe.
But still,
we're not because incrementing means specifically incrementing, but this one doesn't always increment.
okay.
It also does the.
I'll buy track popularity.
But you do, so when you say select, you do have a point, because what we're doing here, you could actually, this is, take all the quizzes. This is some technical stuff dealing with the map, but we could call that select all or something like that. And then say that select all does this sort of infrastructural stuff that we're now hiding. I probably need to pass quizzes here. So now this looks a little bit more like, well, the language of selecting stuff, of SQL, basically.
Is take 10 Haskell thing, or is that something you made?
This is more like an F# thing. It's not really common in Haskell, but it's very easy to. It's basically if you have X arrow F, you're saying that it's reverse function application. So I'm applying F to X. We can write it as start with X and apply F to it, and that's what this this symbol means. So it's sort of,
yes.
yeah. It's I think they call it pipes in piping or something, in, or pipe operator in F#.
So yeah, I think we are basically.
Yeah, we're out of time.
We got a few extra minutes actually, so
Okay.
we can have 10 more altogether, but then we need to leave at 35.
Well,
Okay.
I think we should wrap it at 30 past.
Yeah,
But
that would be great.
But okay, so does it still run, Matthias?
I think, yeah, we didn't rename that in the other, that's the query thing. So that's again the refactor failing. No. So I think, well, if we decide on select and I do it manually, this is the law of demos, that something that works some of the time will definitely not work in during a presentation. But now it compiles and it actually runs. So it works. So I agree that this is debatable, because are we trying to make, basically what I'm doing here is trying to make a sentence. We start with this and then we do that and finally we do that. Or you could keep that in the language of projections and then it's initial state, step, and transform or query or select. So I agree that that's debatable, and maybe a test for that would be to say, does it still work if we try it on a bunch of different projections? Does it still look natural? Start with 0, then here increment or counter, and then this.
Well, I don't. Yeah. So my objection is really, it seems like we've just swapped one set of generic words for another set of generic words. Instead of saying initial, we say start with. But initial and start with are both just generic ways of saying, start with or initial.
Yes,
so,
but we are in the domain of projections. Here we are in the domain of.
So then why not use the language that people use when they talk about projections?
Sure, and then I would agree. So, but basically, I think that the trade-off is sometimes using your domain language in a natural sort of language style to express what you're doing, as opposed to using the terms from. So the terms from.
I hardly agree with that. I'm hardly agreeing with that, but I'm saying that here we really are talking about the projection. we're saying this is how the projection is done. So having clear domainy words for those three things, I think this is our chance to connect the two together. We use the projection language and we say, what is it in domain? I mean, you say the initial state is this in the domain. So the initial state, which is projection language, is an empty recommendation, which is quiz recommendation language. The step is to track popularity, and transform actually, in this case, of course, is more generic than
select.
The 10 most popular, by the way, isn't really, I'm not even sure this is right, because the projection doesn't just calculate the 10 most popular, it also calculates the new popularity of each recommendation. So you start with empty recommendations, and then you get some then each step you update the individual recommendations and you select the top 10. Those are both part of the, right?
I'm not sure what you mean, what the difference
What
is.
I'm saying is that when we get a new event, okay, so we start out, we have a state, and that state would be not just the top 10, the state would be all the...
That state is all of them, right? But here we're explicitly taking the top 10.
Right.
So that's what the 10 most popular does. It sorts on popularity.
But when you have that part up above, you say, okay, so you're saying then that the track popularity means produce the new state.
Yes.
And then the projection beyond that, well, the projection is the selection.
So the projection is all of it together. In my, maybe other people have different definitions, but for me, the projection is the whole thing that deals with the stream of events and produces some useful result, right? And the useful result we want is 10 most popular, but we cannot, well, we could, so another way to do it would actually be to, at every step, only keep the 10 most popular. So basically do this and this.
Because what if one of the others becomes more popular?
Yeah, exactly.
There's no way to bring it back in.
Yeah, so then this is actually
to keep them all.
You're right. So this is the only way to do it.
Then missing here is it's a
completely
little bit incomplete. We have the state, the event, and the state, and the selection from that state. You know, so the state that we're producing two things each time we get an event, right? We're producing a new state, and we're also producing this selection, which cannot be fed into the next state because, I mean, the next event, because it doesn't have all the information that's needed.
But we don't do this on every event. Normally we would only do this whenever we care about, when we query it.
Oh, I see.
So if, let's say, people are playing games and nobody visits the front page, I would keep tracking the popularity. I'm updating that state all the time. And then somebody visits the front page, and then we actually do a query, which takes the present state and calculates this.
Sorry,
Okay,
we should wrap it up, I think.
All right.
Yeah, so let's go to the most key one, which is track popularity, and let's just take one more look at track popularity so that we can see where we ended up. Track popularity is event recommendation, which is the state-to-state thing I was talking about.
Yes.
And we say when the quiz was created, we start tracking, and when the game was opened, we increment popularity. This part seems pretty expressive to me.
Yes. I agree. I think if we had another hour, we would probably change a bunch of things, but I think this would be very stable indeed. It's probably also the most compact that you could express this whole thing in any language.
Perhaps. But anyway, thank you.
Have you tried APL?
Let's.
Them's
That's
fighting
your
words.
presentation
The most
for next time.
possible in any language. Them's fighting words, as we say.
Well, okay, let's add the qualifier and still be understandable. That automatically excludes APL.
I guess we have to wrap up, but
right. Well, thanks so much for joining me. We should
yes, thank you.
Do this more often.
Thank you very much for the session, and thank you all for joining. And don't forget that you can find us in DDD CQRS ES Slack workspace. We created a channel for virtual DDD, so you can find us and ask questions from any of us. So thanks again for everyone, and enjoy the rest of the day. Bye.
See ya.
Bye.
Bye.
See ya.